Okay, let's talk about graphing systems of equations to solve. So on this sheet we have that they want us to show y equals 3x plus 1. Let's consider what we know about that line. This is y equals mx plus b, so the m is equal to 3 right there, and the b is equal to 1 right there. Okay, keeping in mind that m stands for slope and b stands for y-intercept. So I'm going to plot my y-intercept at 1. I recall that a slope of 3, slope is really a fraction, so I'll make that 3 over 1, which is the rise over the run. So that tells me from the y-intercept, I'm going to rise 1, 2, 3, and run to the right 1. And there's my next point. Do it again, so we got 1, 2, 3, and right 1. 1, 2, 3, and right 1. Once I've got a few points, I'm good to use a straight edge and graph my line. Remembering to put arrows on each end, remembering to label the line with its equation. Okay? Hopefully that's no big deal. So now I move down to the next question. On the same axes, show the graph of 2y minus 4x equals 6. First, notice that that is not in y equals mx plus b form. So my first step has to be to add 4x to both sides of the equation so that I can start getting y alone. So I have 2y equals 4x plus 6. I don't want 2y, so I'm going to divide by 2. And I divide everything by 2. And that gives us y equals 2x plus 3. Now that that's in y equals mx plus b form, I can tell that my slope is 2 and my y-intercept is 3. Again, I do want the slope to be a fraction, so it's 2 over 1, keeping in mind the idea of rise over run. Okay, so my y-intercept is 3, so now I'm going to put a point at 1, 2, 3 right there. And my slope is 2, so I'm going to rise 1, 2, and run 1. Rise 1, 2, and run 1. 1, 2, and run 1. So I get a line that looks like that. And that is y equals 2x plus 3. Okay, now this does ask us what observations we make. Hopefully you notice that these two lines cross each other. So first off, we do have two lines. Okay, sorry, I zoomed the wrong way. So we got two lines there. We notice that those two lines intersect. Okay, and we are going to be looking for that point of intersection. And the reason that we're looking for that point of intersection, the solution to a system of equations is the point of intersection. So what you are going to be doing now is graphing two lines and finding out where they intersect. Notice that these lines don't have a story to go along with them like they did the last couple of days. Notice that now we have all four quadrants. Here's the x-axis, here's the y-axis. And we're looking for where the two lines intersect. So in this particular case, if I look really carefully, depending on how well I graph my lines, I see that they intersect at the point 2, 7 right there. So in this particular case, the solution is the point 2, 7. Okay? And what the bottom question is all about is it wants us to show that it works or is a solution to both equations. So keep in mind that the 2 stands for x and the 7 stands for y. So what I'm going to do is write down my two equations the way that they were originally given. I had y equals 3x plus 1. I also had 2y minus 4x equals 6. And what I'm going to do is substitute my x and y values and make sure that they work. So the point of my solution, the 2 was x and the 7 was y, so is 7 equal to 3 times 2 plus 1? Well, 3 times 2 is 6, plus 1 is 7, so that checks out. So yeah, come over here. Again, y was 7, so is 2 times 7 minus 4 times 2 equal to 6. 2 times 7 is 14. 4 times 2 is 8. 14 minus 8 does in fact equal 6. So that point checks in both equations. It is the only point on the graph that will work in both equations. So here is where we're going for the next day or so. We're going to be graphing two lines and finding the point of intersection. If you have any questions, be ready to ask when you come into class. Goodbye.